All right, so we're going to paste this out. We have coffee and 2 Diet Pepsis. So when they're done, we're done, right? I just want to clarify that. There's another thing I want to clarify. I've not been to LISA before, and y'all do things a little bit weird. And the weird part for me is the hour-and-a-half of talking with no questions, and I just can't take it. So, and I don't know why you guys can take it, but I totally can't. So when I say something that sounds ridiculous or something you're positive is wrong or something you have a very important clarification to add, please just go to the mic and I'll say something. And if we get into like a heckling situation, that'll be fun for everyone, right? So, I think. So, I am actually not going to try to tell you where you should go. I'm going to tell you where I think I'm going, and you can come along if you want to. It's kind of up to you. Maybe that's not a significant distinction. I do want to clarify the disclaimer here. It's true that no systems or software engineers were harmed in the production of this talk, to the best of my knowledge. The Engineer Subjects Review Board approved all of the procedures here. So this is a slide that's going to get tomatoes thrown at me. That's fine. I looked for tomatoes in the audience, and I didn't see any. But I'm sort of so biased. OK. I think systems administration is over. And I think we should stop doing it. I think it's mostly a bad idea that was necessary for a long time. And I think it's become a crutch. And I think it's something that is not worthy of us as people. And I think we need to move on. And I'm going to talk about why I think it's bad and what I think is bad about it, and a couple ways I think we can get beyond it. So there's, wait, somebody said something, but they weren't at a mic, so then they didn't register. I think DevOps is helpful and useful and interesting, but I think DevOps enshrines the idea of operations. It reifies operations. My colleagues told me not to use the word reify, but I'm going to use it anyway. Sorry about that. I think we need to go beyond administration and operations by quite a lot, and I think we need to stop doing the machine's work for them. There's a lot of areas where we've already done that, but not nearly enough. So this is going to be like a kvetchy, ranty kind of a thing for a little while. But there's fun bubbled in there. I'll try to stay away from ridiculous, unfun. So let's start with some pictures of ridiculous, horrible things that people used to have to do. This is bad. This is the multiprocessing computer division at the Bonus Bureau, 1924. That doesn't look like a lot of fun. I mean, gainful employment is good, but that doesn't look like a lot of fun. I don't want to do that. I was looking for pictures of machines eating people, because I think sometimes the work of systems administration feels like you're being eaten alive by your machines. It's like they're eating your time, they're eating your life, they're eating your joy, they're eating your imagination, they're eating your passion, right? So I couldn't find any, but of course, inside of 2.5 minutes, Kasky found me 3 good things. So I had found this, which is pretty good. This one's way better, right? And it's got a little 50s retro thing going on there, so that's cool. This one, it's hard to tell, but there's a little robot, and it's got a human brain in its hand. It's going to eat the human brain. That's what I think the process of systems administration comes from. So this is a weird presentation to make here. I don't actually think it's a weird presentation, but I do think it's a weird presentation to make here. So let me establish a little bit. A bunch of people had reasonable who am I slides. So I'm a recovering system administrator. I think a lot of my colleagues at Google are. I think a lot of you are. So yeah, I mean, and there's been a lot. Almost every talk I've been to, and almost every talk you guys have been to that's had this sort of what's going on here, or process, or something about the industry, or something about the future. Almost all of them start with, I was a sysadmin in the 90s, right? I was at an ISP. Were you at an ISP? Everybody's like, of course, you're at an ISP. Why is that? Well, because the stuff that was going on in universities was a good growing ground, but it was all very limited and it was kind of boxed in. And corporate America was just, you're not supposed to say retarded, but they were leotarded, and they didn't, right? They didn't know what they were doing, and it was terribly boring, right? And so ISPs were like, I don't know, there's a lot of people want a lot of stuff, and we don't know how to do it, but here's some open source software and 5 versions of Unix. Can you put this together? And you're like, I think I can. I think I can do that. Or here's a Quagga box. Does it route packets? Only kind of. Only kind of. Better? Slightly better now. So yeah, so I got my first systems gig in the 90s and worked at an ISP and did unfortunate things with NT and calculated checksums for individual datagrams by outsourcing it on Mechanical Turk to third world orphans. No, I didn't do that. But that sounds like a great idea. Doesn't it sound cheaper perhaps than actually doing TCP offload on chips? Anyway, that's a different talk. It's a totally different talk. But when I was doing that stuff, I swapped tapes, right? I devised some keep 8 of the last days and 5 of the last weeks, one of those, and I individually swapped tapes, and the hard drives kept getting bigger than the tapes, so I swapped more tapes and arranged for couriers to come pick up the tape. I did all that stuff. That was great, right? No, that was terrible. What a terrible, terrible, terrible thing to do with my life, to swap a lot of tapes. And if I told each and every one of you what I really want you to do is spend your entire day swapping tapes, you wouldn't do it. But there's a lot of things we do that are just like that. So I'm going to talk about that. So you guys know this stuff as well as I do. And one of the things I don't want to do very specifically is I don't want to get mired in nostalgia at all. I think that this is the only reason for this nostalgia slide is to establish enough credibility with you guys that you won't throw things at me until towards the end of the presentation. I do have a change of clothes, but anyway, we'll get to that later. But I think one of the big problems is this nostalgia. I want to look at where we came from, and that's great. It's fantastic to think about where we came from, but only from the perspective of what can we stop doing? What was a terrible mistake? What's the best thing we can do now? I'm all about those conversations. But when people are like, man, it was so great when I rebuilt the kernel every day. Like, really? Was that great? Was it great when you rebuilt the kernel every day by yourself? And you were like, oh, I answered the wrong thing to that one question, and now I didn't get my loadable module built, and I got to do the whole thing again. Was that great? It was not great. Let me tell you, it was not great. But it felt great at the time because you didn't know what you were doing, and neither did I. All right, so the next thing you have to do, I haven't seen enough of this, but I'll tell my Google colleagues this. The next thing you have to do when you're from Google and you're presenting anywhere is you have to explain why anything you say matters at all. Because the reality is each and every one of you are like, screw you, you're Google, like whatever. It's beautiful and perfect over there, and you guys have problems I'll never have, and it's totally irrelevant to me, right? That's what of course you're thinking that, right? You're like, that's not about me, that's about Google. They have like a computer the size of Mars somewhere that we can't comment on unreleased products, but they have a large source of tachyons and compute things in the past, right? Like negative entropy algorithms, right? No. Again, can't comment. But so this is what I think are the 3 major objections. So one of them is just Google scale is not your scale. That's totally valid. And I think what's interesting about that is, I'm going to talk about this in a minute, but what is interesting about that is Google scale isn't your scale, but Google engineering problems are problems that will become interesting to almost everyone. So some of you heard John Wilkes talk about Omega, our newest job scheduling system and cluster management system. Great. The scale of all of Google isn't what most application developers inside of Google deal with. They run a thing. What is the thing they run? They run the thing that serves pictures. OK. They run the thing that serves Gmail. All right, that's kind of big. That's kind of big. They run the thing that makes the little box turn red if you have a G+ message and you use G+. They run the thing that returns the ads in the upper right-hand corner, but not the ones on the bottom, right? There's all these little services, and each one of those is actually completely comprehensible to each and every one of you, and it's of a size that you can imagine, and it's not dissimilar from what most of you work on. So saying Google scale makes Google irrelevant to you is like saying internet scale makes IP irrelevant to you. It's not true. We use Google infrastructure the same way you use your infrastructure, and doing this provides you a series of taking some of the approaches that we use provides you a roadmap to less toil and less grungy work and more interesting problem solving. So that's my argument about too big. Talent rich, it is true that I couldn't remember the metric. What's the metric for a quantum of software engineering talent? No? It's like an O, I think. It should be an O. It's a Knuth. OK. So yeah, that seems reasonable. So in terms of Knuths per square meter, it is dense at Google, right? We are dense. Yes, I should say that. So it is dense, and that does mean that from an infrastructure development point of view, we can solve a lot of problems, right? Like when people get up and they say, well, we had this problem, and so what we did was we swapped out our global cluster file system for a new one. You're like, wait, what? What? Wait, go back. You had a global file system. Sure we did. We had GFS. It was amazing. And we didn't like it because it had all these things we didn't like, so we built a new one, and we rolled that one out, and we moved everything to it. And you're like, really? That's just mean. I think it's just mean. I thought it was mean because I had to go through the migration. But it's true that like most people can't be like, hey, could you get me a global file system and also make my Paxos-based name resolution scale better because the lookups are a little bit too slow? Thanks. Thanks. Get on that. And people are like, oh, yeah, sure, I'll write that out. Right, so that's true. But this set of approaches, I think, in the industry as a whole are relevant. There is plenty of software engineering and systems development and distributed systems expertise talent to develop open source, standards-based approaches to distributed computation, to distributed cluster management, to distributed job resolution, and I'm starting to see people move in that direction. We're starting to see things like, you know, Zookeeper, as bad as I hear the implementation is, the general idea is quite good. We're starting to see, you know, Mesos for job scheduling, and there's some interesting ideas that are percolating around that will enable people who don't have, you know, 20 awesome software developers in their hip pocket on retainer be able to get some stuff done. Privilege turns out just not to be true, right? That people often think like, oh, Google, you guys fixed all that. And part of that is like because we're kind of secretive, and we take the errors and we lift up the rug and we sweep the errors under the rug, and we're like, nothing to see here. Everything works great. And it is true that there are some amazingly reliable services at Google, and I work on some of them, and I'm super proud of that. But it's true that stuff breaks all the time. And one way to think about this is that we have everyone who's smart, who's doing interesting work, has all the same problems, which is you're always working just a little bit past your expertise, right? We're all always, are you kidding me? Why you gotta do that? I don't know how to. Like, where's Clay, man? The Mac people, they push these policies. It runs putty and bullshit. Where is that guy? Like, this is shit, Max. And now they're telling me I got to update to some new version of something. It's a disaster. Anyway, computers. The refrain is I do hate computers as well. So the reality is we're just engineers trying to solve problems. And we have huge problems that we have no idea how to solve more than half the time. And we look at them and we're like, well, that sucks. Like, what do you want to do? And we look at each other and I'm like, I don't know. That's a really big problem. And stare at each other for a little while. And someone's like, well, are you going to fix it? I'm like, no, are you going to fix it? Somebody's got to fix it. So, Dan, would you fix that, please? Right? This is really, really hard stuff. And so we have not solved all the problems. In fact, all the problems are all still there. And we get new problems roughly every month or two when like massive additional numbers of people decide they desperately need to use more Google services. So our successes and our failures, as we are willing to disclose them, are actually relevant to you guys. Seriously, no questions yet? That's awesome. That's awesome. Nobody's got a kvetch yet? Oh, great. Dan Klein's got a kvetch. Classic.
You asked me to volunteer. So what kind of failures have we seen? Or have you seen?
Well, so what was that like Gmailing Europe thing? That was terrible. Why did that happen? I mean, I know why that was happening. So last year, a bunch of people tried to buy Nexus 4 phones. That didn't work. Why didn't that work, Dan? Don't you work on the payment service?
So it seems that one of the services had anticipated a high load, and so they throttled the service, and that meant that people were hitting the reload button a whole lot, which meant another part of the service was seeing incredible load, and servers were melting down. It was kind of interesting for a while. We had a war room for that one.
Infamous feedback loop through humans. We actually, it is true that inside of Google there are a number of this interesting war stories at scale that involve, wait, if huge numbers of people do it, then it looks like a computer problem. Like it's, infamously the traffic team fired off all kinds of alerts years ago, and they're like, man, global traffic dropped all of a sudden by like 26%. focused in Europe, but actually spilling over into the eastern US, significant parts of the Middle East as well. Well, it was World Cup. Like, and they're freaking California, so they don't know what football is, so they're like, nothing's happening, I don't know. You're like, it's the World Cup final. Like, they're like, traffic in Germany fell by 45% or something. You're like, it's World Cup.
I think it was funnier that they made the same mistake a few years later.
Yes, because it's World Cup, because that comes around again on the guitar, right? Yeah. So I think, I think, look, like anybody who doesn't operate a computing system at global scale isn't going to run into those particular problems. But I do think, like, so every time I point out something interesting that we face and how we try to think about it, I'll try to map that onto much smaller and different systems. And so one of those is you have exogenous inputs into your system as well. And they have periodicity and non-stochasticism, right? They have vertical lines where large numbers of people do the same thing, right? That just happens. Like, North Americans love them some Christmas, and they shop. And if you sell things, they're going to buy them, and it's going to be a pain in your butt. And then they're all going to stop shopping all at the same time. And then you're like, well, everybody was buying things, and now nobody's buying things because human beings are unpredictable and problematic, as we know. So far what we've learned is I hate human beings and I hate computers. Are you guys with me so far? Yeah. It's good. OK, excellent. Excellent. All right, so I want to talk about site reliability engineering. So most of you have heard of site reliability engineering. It's kind of a thing in the industry now, but I gotta say, like, it's still kind of weird. It's a weird name. Is it a job role? Is it a bundle of skills? Is it a way of thinking about problems? Yeah, it's kind of all of those. Is it sort of a weird collection of words? What does it mean? I'm going to talk about how we do production engineering at Google a little bit in the context of site reliability engineering. I think that's what I'm going to talk about. So there's like, they have these leather jackets and they've branded site reliability engineering. Right? See, like, I don't know. Like, so my experience with this is, like, so I work in Pittsburgh. Great. So Pittsburgh's a great little city. But when you work at one of the vassal offices instead of the home office, you start at an office you'll never work at. So like you report for work your first day to California. You're like, that's just weird, right? I'm going to get on a plane and fly to somewhere I don't intend to work to start working. But that's fine. So you do this. You show up and like you go through the HR crap and you get an account created and you get a badge and they give you a computer and they tell you like how queries work in web search and you're like, whoa, that's amazing. And then they tell you some security stuff and you're like, your head's kind of spinning the way sometimes it does, right? Like in a good way. But so I sit down and David Ben-Bannock, who's an ads SRE, sits next to me. He's like, hey, it's your first day? I'm like, yeah, it's my first day. It's like, did you get a jacket? I'm like, what? Did you get a jacket? I'm like, I don't know. He's like, just go to the form. The form's about to close. It's the deadline to get a jacket. I'm like, what are you talking about? He's like, just shut up and do what I tell you. I'm like, yes, that's what I've been doing all day. I will do that. So I like fill in some spreadsheet and forget about it. 5 months later, they're like, here's your leather jacket. So they give us leather jackets. And I think it is, so site reliability engineering has an interesting history at Google. I'm going to give a mythical history. So in the grand tradition of storytelling, this isn't what happened. This is just true. But it's not what happened. It's just true, if you see what I'm saying. So I was Lucas Pereira is one of the earliest SREs, possibly the earliest SRE at Google, one of the first two, and asked him a bunch of questions about the history of SRE. And almost none of this is exactly what happens, but it doesn't matter. This is a better way of telling it. So we're going to go with this. And since you guys aren't going to contradict me because you don't know, it's going to be, we're going to agree on this. Is this good? This is good. This is like Columbus was a good guy. It's the same thing. It's the same kind of thing. Are you with me? You got it? Got it? Yeah? Yeah, I grew up in Puerto Rico. Columbus, not a good guy. So Google, super cheap. And actually, a lot of what Google does is about being cheap, which is weird because it's like $1,880 per Google second or something. Like, it's ridiculous. And yet, Google's so cheap. And the reason Google is cheap is not, like, they pay employees well, and we have awesome benefits. But, like, anything that scales with demand, anything that scales with users, anything that scales with people is a disaster if you're not cheap about it. You will get so far behind so fast, you will never crawl back out. So in the early days, they were both crazy cheap and crazy ambitious. They just believed that this was huge. And they got lucky, right? It turned out to be huge. But so anything that scales with services whether it's linearly or superlinearly is a disaster. It's got to be massively sublinear with the scale. So like add 1 million users, you really got to add less than 1,000 quanta of whatever expense you're incurring. That could be people's time, that could be compute resources, power. You've got to find a way to make it cheaper. This is a big part, like when you read like the OpenFlow announcement and Cisco's like G-scale network. What is that? It's because we're cheap and optics are expensive and traffic engineering is terrible and like we're just unwilling to pay the costs that Cisco and Juniper wanted to charge us for like 8 bazillion 10 gig and 100 gig ports. We just weren't going to do it, right? So we're like, we're so cheap, we'll make our own switch. That's how cheap. And you're like, where else does that make any sense? Like, I'm so cheap, I will start an entire platforms research division just to make an Ethernet switch. You're like, but it makes sense in Google. Once you get sort of over in our magical little strange world, it makes perfect sense. So we have no knock. We don't have sysops in production. So the normal thing is developers run their own code in production. Because in the early days, Urs and Larry and Sergey, they were like, no, we're not going to hire sysops. Run your own code, you lazy bastard. Just run it. Compile it and run it. So they did. But they really didn't like it. And they weren't always very good at it. But the nice thing is that they had really good software skills. And the stuff they didn't like, they're like, well, you know what sucks is release engineering. OK, I don't like doing it. I'm like, great. Nobody likes doing it. I don't think. And does anybody like manually doing release engineering? Building tools, but like doing it by hand? Like compiling things and watching them compile and looking like, oh, look at the 34th error line there. That one's interesting. No, like who likes doing that? That's terrible, right? So they started building infrastructure. They're like, we're not going to do that forever. And then they're like, pushing software is kind of crap too. Like, why do you have to do something to install it? Why doesn't it just install itself? Okay, so they built some of that too. Distributed debugging, task restarting. We started to get the beginnings of the system that John talked about a little while ago. We have task scheduling and start to treat a collection of machines like a machine, like a system that has like a namespace and that has processes and the jobs contain tasks and they can find and talk to each other. This is grand, right? This is all grand. I've spent too much time with the Irish people last week. It's all very grand, yes. There's a little bit of court coming through there. So what we found was that of the early software engineers, some of them had much, much better production sense than others. And those became the first site reliability engineers. So we are systems engineers, software engineers. We solve production problems with software. And that's the mantra, is that we're there to keep systems running in production, but we're only interested in solving each kind of production problem a few times before we figure out a more general solution to it. So there's some, yeah. So the basics. I think site is weird. How many of you are American English speakers? OK, you don't care because you work. Who doesn't work for? Does anybody in here not work for Google? Should we just have a beer? That's awesome. So when I heard site, well, I was like, just kept seeing a bunch of Google. See. So site. Does anybody else think site has the context connotation of a building, a place, a facility? You do. Oh, look, it's all the old people. All right, so fine, world. That's great. Fucking hell.
It's all the people who know English.
No, I think it's all the old people is what's going on.
Same thing.
All right, that's fine. OK, so when I
Modern
heard
English education sucks.
Yeah, well, OK. I didn't receive an education in this country, so, and neither did anyone else who went to school here. Anyway. Sorry. That was terrible. That was just sitting right there, right? It was waiting. OK. So I thought that, but in this context, site is a website. It is not a fair description of what we do anymore. And in large part, that's because the notion of site is so much bigger, right? When Google started, it was like 1 box, 10 blue links, 1 box, 10 blue links. And that turned out to be magic. That turned out to be amazing. There's a few other services at Google now that have completely different systems properties to them. John alluded to 2 classes of systems that we look at. We look at sort of production serving systems. We look at batch processing systems. There's a 3rd class called pipeline data processing systems that sort of run continuously and chew a lot of data and sort of have a different production profile and a different set of interesting systems engineering challenges. But we do all that stuff, and we're called site reliability engineers. So from a production point of view, like, you guys have been on call, you know what this is like. You get paged. The buck stops with us. If the service is down, we got to get it back up. If it's about to be down, we got to figure out when that's going to be. If it's down because it's the network, it's our problem. If it's down because the application is badly written, that would be our problem. If it's down because there's a weird kernel bug, that is our problem. If it's down because global traffic is screwed, still our problem, right? The service is down, you have to get it back up. You can involve your colleagues, you can escalate to other teams, lots of things you can do, but ultimately you're responsible for maintaining the availability and correct functioning of the service that you are working on. Now that's the sort of operations side, but it's not really operations because we try not to do very many repetitive things in that context. So many of the times that you get paged, it's new, right? So as John pointed out earlier and other people know, like what's the best time to do creative, careful troubleshooting? Is it 3 a.m.? Who's with me? 3 a.m.? Yes, right? 3 a.m. You're like, yeah, you know what I want to do is think. I'm ready. I'm ready to really think hard. I need to learn something new because it's 3 a.m., damn it, and now it's time to learn. No, it's dreadful. But this is what happens, right? Like we do have, we're big enough, we have a lot of our services have overnight coverage in multiple places, but like a lot of stuff's new, and when you get paid for it, you're like, wow, haven't seen that before. I sure hope it's a class of things that's like a set of things that I haven't seen in a new manifestation of that, because that would be rad, because that means that in 10 minutes of futzing, I can be like, oh, this is this problem I already know. That's what we hope for. We have many services, lots of data, many machines, very few people. I tried to put the ratio in there, and people are like, people can do math, because later on you tell them how many of us there are. I'm like, oh. All right, so I couldn't put the ratio of like cores to people, but there's a lot of cores per people. It's a lot of cores per people, a lot of services per people, a lot of software complexity per person. We balance a lot of competing demands, but here's one of the nice things. We get the privilege of focusing on the SLA of the service. Like, what are we trying to accomplish? Are we trying to keep it available? Are we trying to keep it available and fast? Are we trying to keep the throughput high? Are we trying to keep the error rate low? We put together a set of things. We work with, I mean, somebody wanted this thing, whatever it is. Like, who the hell knows why somebody wants some of the things that Google does? But somebody wants it. If it weren't there, somebody wouldn't have written it. Like, there's this demand that someone has, and you can describe that in a set of numbers. It can say, like, we want this thing. We want this thing to be like 4 nines of availability at 280 milliseconds or less. OK, that sounds like an SLA. I know how to measure that. I know how to tell when we're not achieving that. And I know what my job is now. My job is to do capacity planning and systems engineering and alerting and troubleshooting and software engineering to make sure that given the set of constraints we have, I kind of think we can do that. So that's my new job. But if you're working on a system where people are like, it needs to be up a lot. I had a bad conversation. I'm going to switch slides and back because like, I don't want you to go to sleep, and Clay won't fix it for me because he sucks and he hates me. I had a great conversation with a director who was building a service that relied upon one of the services I work on. And he sent me a mail and he said, I think we need to discuss what it's going to take to get your service to 5 nines of availability. And I said, wow. Because at the time, we were just finishing up sort of thinking through the new SLA, and we're like, we think 3 nines for this particular service is both appropriate, possibly achievable, and it's roughly what the service needs, and it's what we can afford, and it's the right balance of those sorts of things. So we had a plan in place to get to 3 nines, We were hanging out with like, I don't want to say a 9.5, but anyway, it was not 3 nines. We were less than. So he says 5. I'm like, wow. Dude, that's amazing. And he didn't actually say 5 nines. He said 99.999%. That was in his email. So I was like, this is a very serious conversation because I think we have wildly divergent senses of what's going on here. So we need to get together and talk. He's like, what do you mean? I'm like, there is no plan. There is no way with anything that we're doing on the software, the set of dependencies, the systems and software engineering projects that we have in place, the monitoring, there is no staffing for anything that will get this to 5 nines anytime in the future. There's no plan for that right now. But we could establish a plan. Like, it's all just people and money. How important is it to you? Why do you want to achieve? He wrote back and said, I was using 99.999% as a metaphor. I'm like, all right, so what we've learned is I hate people, I hate computers, I hate my coworkers. Yeah, so for future reference, in case you're curious, numbers are not metaphors. They're numbers. They're numbers. I can imagine circumstances under which you could use a number as a metaphor, but this was not that. Actually, it was. So there's 2 things that we,
So since you brought it up, what's a typical service run inside of Google in terms of nines? Can you tell us that kind of thing? Is
Yeah,
3
sure.
nines or 5 nines acceptable? How does that go?
So it totally depends on the service, and that's why we have really interesting conversations. It's like, what do you want? What do you expect to achieve? Let's take latency as an example. It's not the availability question you asked, but let's take latency as an example. Google published a bunch of data around this that Marissa did some work on early on when she was still at Google. That was like, when do people get bored and give up? And the numbers that we published, this was years ago, I don't even remember when it was, like 2006 or 7 or something. And it turned out that like somewhere between 500 and 800 milliseconds, people are just like, screw it, I don't know what, anyway. You're like, which was amazing at the time, because at the time, a lot of web pages were loading in 2 to 8 seconds, right? And so Google published these numbers, and everyone's like, how am I going to do that? But at Google, they were like, okay, I guess that's the new requirement. The new requirement is to exceed people's latency expectations. So there are tons of services inside of Google that like have availability below 95%. There are services at Google that are so available that the production engineering team, the site reliability engineering team is demanding that the developers and the customers take more risks, make more changes, because the point is not to achieve 100% availability. The point is to achieve the availability target you've gotten while moving the service as fast as you can. And if you massively exceed that threshold, you're wasting money. You're wasting, and for us, I was asked to point this out by Chris Jones. Where's Chris Jones? Anyway, yeah, to point this out. For us, and this is not true for everyone, but for us, opportunity cost is almost always our biggest cost. Like, if we could have, like an ad serving system, right? So, like, you guys don't. I mean, I worked on ads targeting for a long time, and it baffled me, because I'm like, who the hell clicks on this stuff? But it turns out a lot of people click on this stuff. And when it's well targeted, they click on it a lot. They really like it. John misspoke earlier. Please do not click on ads that you don't find relevant, because it screws up my machine learning model. So just leave it alone. If you like it, click on it. If you don't like it, don't click on it, because what will happen is you'll click on it and then you won't go away, and there's a model that tries to determine whether it was a good click or a bad click based on some other. It's just a disaster. We don't want to do that. So just click on the stuff you like. Don't click on the stuff you don't like, and let God sort it out. Yeah, Dr. Klein.
What about Romney ads?
Do you like them? No, dude, that guy has a healthcare plan. Have you seen it? Holy crap. Massachusetts? That shit is badass. Oh my God. There's like a marketplace and you can shop for stuff. It's totally, you're going to love it. Yes.
How do you talk about promoting reliability with an ads learning model where the company makes more money when it goes down?
Because, oh, sweet. See what you did there? I tried to move it, right? At least I'm typing my obscenely long password more reliably at this angle now. It is true. So two things about the ad serving system. One is that there is an opportunity cost that is really, really important to us. If we can come up with a better way to serve more better ads to the right people who are excited about those ads in a way they don't find annoying, that is massively valuable to us, to the advertiser, and pretty significantly valuable to the user. I've been shocked that I've seen data that shows that the vast majority of users, again, I'm assuming not us, but the vast majority of users significantly prefer search with ads turned on than with ads turned off. And I find this baffling. I've seen the data, and it's super, super repeatable. And I can only assume that it's because, again, people are terrible, and like, I don't know. Yes?
Well, I always wanted to pay for the service, and I thought if I clicked the ad, I could certainly ignore it and be paying Google something. I didn't want you guys to go away.
Yeah, well, it's not a big concern. I think we're doing okay on the money front. So, I'll have to check, but I'm pretty sure, like, maybe your support in the early days was most welcome. At this point, if you don't want to see ads, don't see ads. If you don't want to click on them, the single most important asset in the ad serving system is the user's attention, right? So I value your attention so much, so that if I look through the ads and I'm like, all right, so you searched for tractors, and the only candidate ads, maybe for some reason our salespeople were terrible, the market is weird, we have no tractor ads. I'm like, I know what I'll do. I'll serve you ads for yoga pants. and weight loss. I'm sorry, yoga pants and weight loss and some milkshake. I don't know, like I'm gonna serve you some random ads. No, we just choose not to serve any ads. If we don't get an ad that we think is good enough, that there's some significant chance that you don't have to click on it, you just have to not be angry about it, right? Your brain has to get the signal, oh, there's stuff over there. I mean, I don't like it right now, but there's stuff over there. The same way you do if you're like paging through a physical newspaper or you're on a website you go to and there's some little box that typically has something. You don't always read it, but like they want you to think, occasionally there's something over there, so keep looking. Keep looking. Every so often I want to serve you something there that you would actually like. That's the Weasley answer. The real answer is there are systems inside of Google that have 4 nines and a 5 and 5 nines of availability as their SLAs, and they routinely achieve them. There are plenty of systems that have weird SLAs, like X hundred milliseconds of latency at 75th percentile. Like that was published in one service that I relied on. I'm like, I don't even know how to do reliability engineering on top of a 75th percentile. I'm not denying it's in the solution space of possible SLAs. I just don't know what to do with that. Like, I have a thing about 99 and I have a thing about median, but I don't know what to do. Like, anyway, so actually a lot of teams didn't know what to do with that, so they changed that SLA. But it turns out SLAs are partly culture and partly numbers. So there's one other thing I want to talk about, which I think I've mentioned, but let me say explicitly. We're there to move things quickly. We're there to launch software as quickly as possible, launch new features. We get to be the cranky people who say, like, I want the thing to work. But the only reason we get to do that is there's someone in the development engineering side who's like, I want to launch the new thing. We're going to get to that in a second. So so one of the things that we spend almost all our time on is post-deployment evolution of a service. A lot of software engineering and production engineering spends a lot of time talking about like what happens before you launch. And then a lot of operations engineering assumes some sort of box that, like, there's the huge wall and the trebuchet that flings the packet of software at you over the wall, and then you don't know where it came from and it lands in your lap like a pile of poo, and you're like, this is not very good. And they're like, okay, run it, right? So that's what you have, and it's usually terrible, not because the software is bad, but because the software is usually almost good, right? Which is way more frustrating. If it were terrible, you're just like, it's terrible, I walk out, right? But if it's almost good, you're like, I can do this. All I need is, I need to detect when the requests that caused the memory leak happen at a higher rate than I expect so I can trigger the restart. What? No, you need to fix the memory leak. Stop it, right? But in a lot of cases, we don't get that luxury. We always get that luxury / responsibility. But there are massive amounts of evolution of systems post-launch. I'll give an example from one system I worked on. So we have a distributed key value pair in memory, as one does, right? You're just like, I've got some keys, I've got some values, let me put it in memory and distribute it on a few hundred machines. Because, I mean, like, it was a Saturday. It seemed like the thing to do, right? So that was fine. So we did that, and we wanted it in RAM. The old version synced it out to disk, and it turns out there's these spinning platters, and the heads are, it's terrible. You guys know about these things? They're terrible. I mean, huge capacity, but like, oh, man. Things like 100 per second per spindle, what is that? Like, that's useless, right? We need a lot of I/O ops. So we're doing that. It's great. So it's in RAM, and we had it syncly homed in RAM. So each portion of the key space was syncly homed in RAM, and it's going to have an epoch so that if one of them crashes or restarts, it's going to be OK. So an epoch is defined as some number of minutes. We were about 20 at this point. So we're like, after 20 minutes, we're going to sync it all out to permanent storage in the magical cluster file system I previously referred to. It's going to be great. And then if anything goes wrong between minute 0 and minute 20 plus this time to sync, we're just going to declare the epoch a failure, roll back, and do that over. And as long as that doesn't happen too often, it's fine. Worked great for months. New system launches, like, because we were pretty concerned. We're like, there's only a single one of those. But we did some math. We're like, carry the one. It's fine, right? OK, it works. That's good. OK. All of a sudden, all progress halts. Like, all learning, this is one of the machine learning systems, it has made no progress for 8 hours. Not like a little bit of progress. It's not that things slowed down. It has not successfully completed one of these epochs in 8 hours. That's less good than we expected. OK. So we look at it and we find that the cluster infrastructure team is going to do some kernel updates. Because kernel updates are good. You don't want old kernels. They get smelly and they get a little mold on them or something. I don't know. They're bad. Kernel update, old kernel's bad, new kernel's good. Right? So they're going to do kernel updates. the kernel, so Google is not a pipeline processing company. They're not actually even a batch company. They're a serving company. When you think of like all the awesome things about Google, Geo, right? Maps are awesome. Right? Search is great. Even the ads, you're like, God, it makes a lot of money. I don't know who clicks on it. But these are serving systems. That's grand, right? But for the pipeline processing systems, they kind of think, you'll be fine. You'll be fine. We'll engineer for the serving systems, and you'll be fine. So when they do updates of machines, any kind of an update of a machine, they take out as few as possible in a rolling fashion as you go through a cluster because you want to preserve capacity. What kind of capacity? Serving capacity. That makes good sense, right? You wouldn't want to take down too many things, right? OK, so remember our model. I've got a few hundred machines. And if any one of them goes down in any 20-minute period, I'm going to have to start over. So what happened is the rate of kernel updates approached the point at which the probability in any given 20-minute period that one of these hundreds of machines would go down was 0.85, right? So every so often we get to that 20 minutes plus the sync time and be like, yeah, I did 20 minutes worth of learning yesterday, all day. It was terrible, right? So this is what this is referring to is this emergent behavior and interactions with other systems. Like, was this system bad when we deployed it? I mean, certainly, like all systems, it had bad things about it, right? Like I told you, key value pair distributed in RAM and a single copy of each key in each value, right? You're like, well, that sounds dumb. But if you think about it, like, what are your trade-offs, right? If you were going to do that differently, what would you do? Someone tell me what would they do differently that would be cheap and efficient? 3 copies. 3 copies? So you're just, OK. So like you're going to burn 3 times large number of terabytes of RAM. You can. I mean, it's not very cheap, right? And there's actually another problem, which is even worse. If you have multiple copies of this, you want to do one of 2 things. You either want to do distributed transaction locking, which is going to slow you the hell down. You're like, I'm going to write to you, and you're going to write to him, and he's going to write to her, and we're going to hold on here until everybody agrees that they've all written the same thing. You could do that, but man, before you were like, RAM, RPC to you, you write to RAM, we're done. This is badass, right? And now you're like, I'm going to sit around and wait for a transaction to complete for every key update. So that was pretty bad. So we thought about that. There's other things you could think about doing. We solved the problem in a different way, which is we sort of we told the kernel updater, hey, do me a favor. Just let me know when you're going to update. And let me just hold on a second. And I'm going to sync this stuff out as fast as I can. Right? And that's a kind of weird middle ground because like ideally you're like, oh, I should have 2 or 3 copies of everything because that'll make me resilient. But it's also really expensive and slow. And the only reason we went to the RAM-based system was because it was fast, right? So in the middle ground, we're like, if you're going to do an update, hold on and we'll sync the stuff out to disk. So this is the kind of systems and software engineering that SREs do at services at Google where you're like, well, there's nothing wrong with the service. In principle, I mean, it could be better, it could be different, but it was fine. There's nothing wrong with updating machines and clusters. That's fine too, right? But the intersection of these 2 particular behaviors gives very bad emergent problems. OK, and then the environment, yeah. So I think we've covered that. So all right, I'm going to talk about people for a little bit. Now, we've previously established, do you guys like people? You don't, right? That is a great question. What is the alternative? We don't like people. We don't. We're going to have pictures of cats later, and I think they may be the alternative. So there's been a lot in the DevOps, so we're going to talk about DevOps later, but SRE turns out to be a separate organization from the development organizations at Google. And what's interesting about that is it doesn't have to be that way, right? Because we could have this set of functionality embedded in developer teams. That's fine. We could have it be a completely separate organization the way we do. There's a bunch of different models where you could sort of assign SREs temporarily to teams to work on launches or to work on consulting on production problems or whatever. But it turns out we're a separate organization. And that turns out to be way more important than I think we understood it to be when we first started. So I think like a lot of things at a lot of successful organizations, total mistake, total fluke. It's probably not fair. Probably Urs would be like, I knew that was right from the get-go. You're an idiot. He would probably say that, and he's probably right. But so SRE teams, the whole organization is independent of development engineering teams that work on particular products. But each team is tightly coupled with 1 or more development engineering teams who work on either technologically similar projects or thematically similar, usually technologically similar. So there's like a web search SRE team. There's actually 3 different web search SRE teams. And there's like 3 ad serving SRE teams, right, that work on the ad serving systems for content ads, display ads, and search ads, right? And then there's 2 different geo SRE teams that work on different aspects of the maps system, right? So they become close colleagues with and joint production experts on and implementers of set of technologies. But by being independent, they can stand back and say, that was a bad idea right there. There's actually something more important and more interesting, I think, about the independence, which is you get a freedom that is super necessary to ask really dumb questions. Man, there's some dumb questions that have dumb answers, right? So if you're the junior kid on the new team and you look at some design that your betters and elders have produced and you think, I don't get it, but that looks dumb because there's just boxes and there's one box. It looks like everything goes into the one box and comes out of the one box. And I don't understand why there's only one of these. Well, like, this looks bad. Like, and you just have a question. You might not say anything because these are your colleagues and you don't want to look ignorant and like, you got to work with them and you don't want them. And it's probably a dumb question. I mean, it probably is a dumb question, right? Because most of the questions most of us have are pretty dumb, but sometimes they're not. And so if you're not on that team and you're new to the service and you haven't been writing the code on the service yet, but you're just trying to figure it out, you can just ask dumb question after dumb question after dumb question, like, what's your like data retention plan? What? Okay. How much capacity do you think you're going to need in 3 quarters and why? Huh? Like, you just ask these questions, and some of them, like, some teams will have amazing answers. They'll say, like, oh, look, here's a logistic regression of our last capacity of organic growth. Here's a new system we're going to launch. It requires this much more of this kind of capacity. So, you know, for Q4 in 2018, we expect to need exactly this much capacity. Like, there's teams that are like that. Most of them are like, I think we need more stuff next quarter. Like, I think you do too. So I think that the independence of SRE has been pretty significant. The other thing that's pretty significant, going back to the first slide, is that SREs are in short supply. There's just not very many of us at Google because Google's cheap. And ultimately, our job is not just to provide expert production engineering work on a set of important services. It's our job to evangelize a set of excellent production engineering practices and pieces of knowledge to the rest of the organization. You guys are getting tired, so I'm going to go even faster. It's going to be great. We're going to switch to Spanish in a minute. So there's been a lot about like whether production engineering of this sort should be a separate role. And honestly, I don't know. Like, I think that the work of SRE is something almost any talented developer can learn to do. But here's how I describe it to people who say, they come from a software engineering background. They're coming straight out of school in some cases, and they say, I don't know if I want to do this thing. It sounds like sysops. I don't like sysops. Okay, what do you want to do? And they tell me something. I'll say, like, well, here's the thing. Has anyone you work with ever called you a cranky jackass? And they're like, what do you mean? I'm like, does anyone ever think you're kind of cynical and kind of pessimistic? They're like, they do. I'm like, welcome to the club. Welcome to the club, right here, right here. It turns out you can make money being cranky just by doing this shit for profession. Like, people will pay you to be cynical, right? But so the thing we don't get to be like, no, that's bad. We have to say, hey, you know what that thing there is bad. And you know why it's bad is this. And you know how it's going to break? Let me tell you how it's going to break. I got a pretty good idea. It's going to break like this because this. If you can do that, if you can say, that's terrible, because, and will break in this way, because. If you can do that, then you're an SRE. If you say, that's terrible, then you're just a crank, right? Which is fine. Most of us know, like, software is terrible, right? Have any of you ever seen any good software? Really? Oh, Jesus Christ, more Knuth stuff, man. Typical. Yeah, so software is terrible. Like, everything you've ever written is terrible. Everything you've ever read is terrible. Like, everything you thought was beautiful is terrible as soon as you understand how it works and you're positive you could do it better now. Software is terrible. That's fine. Like there's a bunch of developers who are like, how can you say software is terrible? And we're like, because it is. Like, you admit it, and you point at something, and you spend some time talking through something, and people are like, yeah, that is. We did have to make a series of unfortunate trade-offs over here. I'm like, yeah, of course you did, right? But that's fine as long as we can all admit the software is terrible. How do we get it to work properly? So SRE's been catching on. I don't exactly understand why, and I have a little bit of concern that what other companies do with people they call SREs are not exactly what we do with people we call SREs, but we'll just take it for the success that it appears to be. So we're going to talk about that more later. So what about DevOps? People talk a lot about DevOps. What about DevOps? You guys like DevOps? Didn't I just describe DevOps? Isn't SRE just DevOps? Aren't these just like annoying marketing words? But that's almost certainly true. These are just annoying marketing words. So it's obviously a cultural and professional movement. I think we are all required to put that in every slide that mentions DevOps right there with a little footnote for Adam Jacobs, because that's what it is. It's a buzzword. It's a trend, a fad. There is a very, very nice component of it, which is trying to get rid of the silo between development and production. Like, we have done that in a different way. Most organizations haven't done it at all. So to the extent to which DevOps is about taking seriously the idea that the production deployment of your system matters and that like it should be an important part in the early specification and design of your system, that's awesome. That's fantastic. That's a lot of fun. Yeah, there's a bunch of, put some stuff on there. So I want to look at two issues about DevOps that I think are interesting. Maybe interesting is the wrong word. Maybe troubling is the right word. So one of them is organizational structure. You see how we're in the second? Everybody know, like we're in the first of the diet. So the coffee's gone and we're getting into the Diet Pepsis, just to let you know. So one is the organizational structure and the other is the role of operations. So in the traditional organizational structure, so in the classic organizational structure, development's over here and operations is over there, and there's, again, the large trebuchet and the highest brick wall that any manager knows how to build, and you keep these things apart. And as far as I can tell, it's kind of weird. They keep them apart because developers are valuable and sysadmins and systems operators are useless. I don't know. I've actually never understood why it's so important to not let the operations folks talk to developers. But a lot of organizations have that. It's really, really important that you not bug them. They're thinking big thoughts, like how to make the next awesome memory leak. They're just big, big thoughts. They're just really sophisticated, subtle thoughts. It's weird because I think two really bad things happen. There's a lot of bad things that happen about that. Most of you either do work or have worked in places like that, so you know what I'm talking about. One of the worst things about that, from my perspective, is that we have encouraged system administrators to think they're not developers and think that that's okay. And this is a tragedy because you know what? It's all software all the way down. Bring your own turtles, right? It's really just all software. And if you think that that it's okay to pretend that software is abstractable and you think that it's okay to not be able to read, write, and modify code, you're going to have a bad time pretty soon. You're going to have a really bad time. So I think a lot of organizations structure things in a way that encourages that. To say you can't look at the Oracle source code. I'm not sure you would want to, but you really can't. And you can't look at the MySQL source. Why can't you look at the MySQL source code? Of course you can, right? This is just selects and reads and writes, and it's all just syscalls all the way down. It's fine. Yes?
Do not look at the MySQL code.
No, it's fine. Whatever. All right, it's not fine. But if you, at some point you got if you're going to run it and you're going to run into problems, you're going to have to look at it, right? So DevOps says, no, we're not going to do that. We're going to establish one of the ways you know that it's not just a cultural and professional movement, but also an important buzzword is the value chain is used in there. There's going to be a value chain, and you're going to be a link in the value chain. I don't know. Maybe you're going to be a part of the value. Can we have a value tube or a value tunnel? I'm trying to think all the ways we can move value around. Maybe like a value canal, a value gracht, right? That was good. So a value dump truck, I like that. But then you have to have quanta of value. You don't get continuous value, you just get, anyway, discrete dumps of value. All right, this has gone badly wrong, as do almost all metaphors. Moving on. So DevOps says we're going to mix this stuff together, and we're going to have we're going to let people talk to each other. And in this respect, I think this is fantastic. Yes, as much as I dislike people, I think they should talk to each other. I think it is less bad when people talk to each other than when they don't talk to each other. I'm sure I will come to regret that soon. But let's say that I think that right now. So now we're going to integrate that stuff, and we'll be all one happy jumble of stuff. So that's pretty good. That's OK. But the organizational structure involves DevOps as a set of functions of people embedded with people writing applications and people building infrastructure. And I think that's fine for many organizations. I think that we have found, at least in the services that I've worked on at Google, that the independence of this particular set of reliability engineering turns out to be a huge part of the value. And that in particular, when you embed people whose primary concern is production engineering and reliability into the team whose primary concern is making the button blue, right? The button, I'm positive it's important that the button is blue, because people who care about blue and people who care about buttons tell me that if the button's not blue, we're not going to be ISO 9047 compliant, and this is going to be a problem. So we're going to ship a new version of the website, and it's going to have a blue button on it. It's going to be grand, right? But I actually just want the website to serve requests at an acceptable rate. Like, I want it to have like 4 nines at 250 milliseconds. And for some reason, the blue bits serve much slower than the pink bits used to serve. And so we got to solve this problem of serving blue bits quickly. And having that independence to say, like, it's your job to ship the blue button, and I want to help you with that, but it's my job to serve buttons, right? And so we have to come to some terms. So the embedding of it, I think, is kind of concerned. There's a I think that's a quibble, right? That's just me saying, I think the independence is really important. You should consider that as you sort of go forward and think about the role of yourself as a production engineer and a systems engineer, and the way that your independence of people who are shipping new versions of software matter. So that's fine. There's something more important about DevOps, which is I don't think I've ever seen anything in any of the DevOps presentations or literature that involves getting rid of operations. I think it actually enshrines operations, says we're going to do operations. A bunch of the next things I'm going to talk about is about getting rid of operations. I just want to get rid of it because I think it's kind of dreary, and it's a good learning ground, and then we need to do as little of it as possible. So yeah. So a lot of you guys saw this. Adrian Cockcroft at Netflix caused a big ruckus about saying no ops, and people got angry. And then some people decided that was what they meant all along, which is sort of, have you guys read Thomas Kuhn's Structure of Scientific Revolutions? Yeah, it's right. Like, you're like, that doesn't make any sense. You're crazy. That doesn't make any sense. You're crazy. That's wrong. That's what we meant all along. Those are like, that's sort of, and so, now in the modern age, so when we were thinking about like, is light waves or particles, or is electricity, spectrum, what is it, right? So that used to take, a scientific revolution in conception around an individual item used to take, I don't know, between 20 and 80 years. So we can do it on Twitter in 24 to 48 hours. So that's kind of awesome, because we can go from, you are a madman, to I've always agreed with everything you've always said all along, and you're just making my point for me really fast, which is good. So we can all agree. I hate people. Okay, so yeah, so Adrian pointed out that if you have a platform as a service, you don't need operations, because you're not addressing, you don't need operations as they are traditionally defined. Developers can talk to directly the platform that they're deploying their services on. And you might say to yourself, well, someone has to do operations, right? And that's actually strictly true, that someone does have to do some operations. But two things are going to happen here. One is there's going to be a collection of people who specialize in building and running with as little human effort as possible and as much software as possible a really, really scalable set of distributed services that other people use, right? And we're already moving towards that. There's going to be other people who just use those services, right? So services, and you've already heard this, this is sort of the mantra of everyone at Google, is like, I just don't know how you guys deal with VMs. I know, like, this just seems like a lot of hassle. Seems like a lot of hassle. You got some code you want to run, just run the code. And I know, like, well, you have some old code. Somebody said all your code's Fortran. We can't comment on unreleased products, but I'm sure Fortran's going to be on the big cluster pretty soon. It's going to be grand. Google Compute Engine. No, we're not going to ship Fortran to the best of my knowledge. So services, not VMs or machines, certainly not machines. You just don't want to be thinking about machines. But it is true that, so a lot of configuration management. I think all of configuration management has concerned itself with configuring individual instances of operating systems until now. Like that's been a huge part of what people have spent a lot of time doing. And that's really good because configuring individual instances of operating systems is dreary and frustrating, and the degree to which they're not exactly the same or auditable or reportable is terrible, right? So focusing on that was a great thing. So that's, I don't want to say that's solved, but like we have some really good tools, and it's way better than it was 5 or 10 years ago. And the next step of configuration management is going to be to configure services. And it turns out that you have all the same complexity, but we just get the chance to not make all the same mistakes, right? So if I want to say, I want to run a service, somebody tell me some service I want to run. Someone tell me a service I want to run. No services? What? Gopher? Yes. Okay. Rad. Gopher. No, Gopher. It's the gauntlet has been thrown. I want to run Gopher. All right, so I've got a collection of data, the files that people are going to get from Gopher. It's in a structured directory of some sort. And what else do I have? I have the little Gopher picture from the University of Minnesota. I got to have that distributed around the world. I want to have relatively low latency to as many of my users. Where are my users? They're probably, you know, Western Europe, Eastern Asia, Southern Asia. So I'm going to have Gopher front ends. And I'm going to like, so if you think about the latency of the service, you don't want to take forever to fetch a file via Gopher. You want to get your files pretty good. But you can't replicate, maybe you can, but you probably can't replicate all of the Gopher files everywhere. So we're going to have to like maybe have some geographic sharding. Like it's possible, for example, that the Han Korean content is mostly accessed in Korea and the west coast of the US, and it's not accessed very much in, say, China or in the east coast of the US or Europe where people don't speak any Korean. I think we have to assume that people are going to have a lot of porn and a lot of TV shows and movies in Gopher, so we're going to want to provision for Gopher distribution of you know, a bunch of binary files that are really, really large. So we're thinking through this. You say like, okay, how are you going to configure that service? Like, we're like going to think it through. Like, I need some front ends. I need some storage systems. I need some jobs that replicate and audit the files that I have. I'm going to need to deploy all that. That turns out to actually be quite a lot of configuration, right? Like which data centers are you going to deploy all those front ends in? Where are you going to put all the files? Which jobs are going to copy the files and audit the files? And how often will those jobs run? How are you going to synchronize the files? How are you going to audit that like you have enough capacity in a particular place and not a particular place? So I can imagine easily that being hundreds and possibly even thousands of lines of configuration for the new global Gopher service that we have. That's kind of terrible, right? Again, so all I'm saying is like this is the part, remember where I said like we haven't solved all the problems? We haven't solved this problem, right? Like it's really interesting that you pointed this out because I've been thinking a lot about this. Like we have not solved the configuring services problem in the same way that I think the industry at large hasn't fully yet solved the configuring machines problem. It's still there. Still there, right? We're still stuck trying to figure this out. And we're going to figure it out, and you guys can help. I think a lot of people are going to have to think a lot about that. So let me talk briefly about, because you got to have like a little academic diversion where you like talk about somebody who's got a PhD who published some stuff. It's really important. Or business school stuff. That stuff's good too. It's good for slides. So you guys know all about operations management, operations research, this stuff. Everybody's talked to you about it for a while. It's cool stuff. It's about like, you know, what depth to deploy, bombs to try to get German U-boats to ship cars faster out of factories. Anyway, it's something like that. It's about extracting value from a fixed set of assets. And the assets aren't as fixed as you might think they are, but I mean, that's what it is. Like we have a set of constraints and we're going to solve for those constraints. And it turns out to be a really, really useful set of techniques for that. It's a useful approach. It's cool. And so a lot of people have looked at this stuff and said, hey, like, first of all, it's a cool set of ideas. Like, you're blowing up submarines, so I'm going to listen to stories about blowing up submarines. That's good, right? And then you're manufacturing cars. And everybody who does anything about process is like, if you can tell me how to make a car better, that'll be exactly how to do heart surgery. Because I know, like, planes and cars are the way we should do everything, right? So that's good. And it's got math. There's math involved. So like you blowing things up, making cars, and you've got math. This is going to be the way to solve systems engineering problems. Like 1, 2, 3. This makes sense, right? Like this kind of sells itself, I think. So So it's got some really good stuff. But I guess I don't want to mock it too much because I actually think there's really, really good stuff in here and there are applications to what we do. But I do want to say that like as you read this stuff, and there's a bunch of recommendations for stuff to read, I want you to think carefully about what are the constraints that operations research and operations management research have been working under, and what are our constraints? So what are our constraints? Like, it's all just software, right? So from the perspective of software, it's pretty straightforward. Somebody types some stuff. They type mostly the wrong stuff too slowly, and if they would type the correct stuff faster, everything would work right. This is roughly right. Like, I mean, modulo, anyway, there's some details, but you know what I'm saying, right? Like, the degree of malleability of the infrastructure that we work on from a software and services perspective is enormous. It is infinitely malleable, right? Now, we have power constraints, absolutely. We have network constraints, and we're turning those into software constraints as fast as we can because that's better for a variety of reasons, right? We have physical constraints, like at some point there may be companies that can't buy enough disk drives, and so they may have to do something else because there may not be manufactured enough disk drives, right? So figure that out, right? Compress something or come up with some codes or something, do some stuff, right? But there are constraints, but I think that what's interesting about that is that the constraints are mostly irrelevant to the problems we have to solve. We're not even close to optimal on this stuff yet. So what I think is interesting is that when you look at, oh, this is awesome because the sun just set. Yeah, that's all. I'm going to leave it. It's fine. You guys will get sleepy. It'll be nice. So if you get paged in the middle of the night and like it doesn't wake you up as much, anyway, that could happen. So I think that there are a number of constraints that we operate under, that you operate under, that are real hard constraints. Like you only have the physical servers you have. They have the compute capacity they have. You have the RAM that you have. But anytime anyone pretends that the software stack is a constraint, that's not a real constraint, right? And thinking about it as a constraint and enshrining it in your optimization analysis as a constraint is a terrible idea. So I think when you're thinking about maximizing the performance and approach of a software-based service system, like you can optimize a bunch of things, and you can choose to treat any part of your infrastructure as a constraint, but keep it in the back of your mind. Like, yeah, we can only do X, Y, and Z because LDAP. LDAP's not a constraint. LDAP's just what you're using right now, right? You can choose to keep using it, but don't ever pretend that you couldn't like write a brand new protocol that's just like LDAP but has an extra bit onto the end of it because that solves your problem. Like don't pretend that you couldn't do that. Don't pretend that you can't go back to XML because that was awesome. SOAP was the greatest thing ever, and like anybody who said otherwise is lying. No, right? Like you're not going to do that. No, you're not. You're not going to. I'm worried you guys are going to do that now. So I think that's the thing that, that concerns me about operations research as applies to software infrastructure. So I don't know. Here's the interesting question. Like if you deploy a set of applications to EC2, what's the fixed asset you're depreciating? Like what is the fixed constraint that you are operating under? You don't have a factory. Yeah? Time. It's not a fixed constraint.
How fast can you make money to pay for it? Absolutely,
yeah. So, but that's what's nice is that's not in the spirit of operations research something that we're optimizing for, right? Like that is not a set of constraints that you are optimizing for. That's a different kind of problem, and a good problem to have. Okay. We're going to talk about babies in bathwater later. There's this metaphor in English about babies in bathwater. So I do want to say, like as cranky as I am about operations, I spend a lot of my time like trying to squash out operations. I'm like, how many times did we get that alert? Like, I don't know, 4 times last week. 4 times last week you got the same alert for the same thing. Like, well, what are we going to do to fix that? I'm like, I don't know, we can't figure it out yet. You're going to get paged for it at least 4 more times next week. It's not going to get better. So I spent a lot of time hating everything about operations, hating bug scrubs. God, do you guys love scrubbing your bugs and like reprioritizing them until they're just lined up in the right order and everything has the right priority? I mean, you took all day to do it, so you didn't actually do anything, but those bugs are prioritized, and you feel good about that. Like, you know your bug list. You feel good about, like, now it's time to go home, exhausted from scrubbing your bugs. Like, I hate that, right? I want the bug list to scrub itself. I want the bugs to auto-disappear because they magically got fixed and the thing that they were constrained against is updated. And like, I don't want to obsolete a bug. I want the bug to say, like, I depend upon X version of Y sets of things, and those are no longer deployed. So this bug is now obsolete. See you later. Like, that's the kind of thing I want. And I would expect you guys probably want that too. I don't have any idea how to get all of that yet, but I think that collectively we owe it to ourselves to think about that. But all that said, I think there's some amazing things about people who come from a systems operations background and a network operations background that you don't get in people who have a pure software background. I think we care about things working. I think we're amazing troubleshooters, right? So if you write software, you sit down and you're like, I'm going to write some software. You're like supreme optimist, because if you're going to write some big software, like, you believe you can do a big thing. There's a thing, and you're going to do it. It's going to be big. It's going to be cool. It's going to be amazing, right? So you're an optimist, and like, that's a little foreign and weird to many of us. Right? You're like, why would you think that's going to work? Software is terrible. We already covered this. Like, your software is terrible before you write it. It's all already terrible. So that's what we all feel. So that's why some of us have trouble like actually just sitting down and writing some software. But the other thing is that when you're writing software, you are solving algorithmic problems in a constructive fashion rather than solving systems problems in a deductive or scientific investigative fashion, right? So if I'm writing code, I'm like, I got to figure out how to do this. The closest you get in large-scale software engineering is distributed debugging. That's the closest thing to what people like us do all the time, which is, you've got an error. OK, the error comes from a binary I've never heard of. Why would that stop you? Like, you've got an error. There's some logs. There's this binary. It's like got configuration. Figure it out, right? And most of us are like, OK. Right? And a lot of people who aren't in this kind of frame of mind, who don't have a production engineering perspective, are terrified of that. They don't want to do it. So I want to keep that. I want to keep the troubleshooting. I want to keep the constructive pessimism. I want to keep an emphasis on capacity planning. I want to keep this ethic of privacy and security that we've got. Like, I think a lot of us care a lot about our users, and we care about their data, and we care about the integrity of all of the data that they produce in a way that's like, it's not abstract to us because we swapped the stupid tapes, and we're like, freaking swap the tape. But even if we don't swap the tapes anymore, like, we've had to do a restore, and we've known people who have lost data that can't be recreated. We've known people who've had their private data exposed in a way that damaged them personally or professionally, right? We care about this stuff. I want to preserve all that. I just don't want to scrub bugs, and I don't want to be a keyboard monkey. So if we can find a way to do this, keep these values without having to do crappy work, I'm going to be psyched about that. So I'm trying to think about this transition from an operations culture, which we've had for a really long time, to a DevOps culture, which we've had for a little while and is still gaining steam, and I think it's good. I think it's a good transitional step, to a no-ops or a post-ops culture. Not in the post-operative sense, like some of you have had surgery. I've not ever had any surgery. I'm trying to stay away from it. But I want to get beyond this where we're actively eliminating operations as a set of things we do. We're not glorifying it. We're not telling war stories about it. We're not telling everybody they should do it. What we're saying is, oh, no, that's what we used to have to do. Like, that's the bad stuff. That's like, I want to be part of a group of people who say, like, oh, that was terrible. We fixed that. Oh, no, you don't have to do that anymore. Like, floppy disks, I don't want to say, like, yeah, floppy disks. I want to be like the guy who's like, oh, no, we have networks. Don't worry about that. No floppy disks. Those are terrible. Don't want to use them anymore. I think we need two things that I haven't talked about yet. One is I think we need enough operations to figure out what are the software problems we solve, right? We will deploy these things in production, and we're going to figure out how they fail, and we are going to figure out what to develop next in the system, how to engineer it. There's one other thing that nobody talks about. I mean, people talk about it, but they're like, I don't want my boss to find out that everybody here thinks he's an idiot, right? Because you don't want to do that. But the reality is, if your boss doesn't know what you do and doesn't know why it matters, one of you is not doing their job, right? And it's probably your boss, actually, because you're here, and so your boss isn't going to yell at me because he or she probably isn't here. What I mean by this is that there is an enormous, enormous value in technical expertise going all the way up to the top of an organization, and I think we should demand it of our bosses. Like, I think we should expect that. Yes?
How much technical expertise do you think management needs, and like, how do you define understanding of the job?
Well, let me ask you, like, what do you, like, so what do you do? Like, what kind of work do you do?
I'm a product manager,
okay.
And I'll say non-technical. I have a good understanding of what they do, but I can't code myself. Like, I can't look at code and debug code, but I know what people do.
So I think there's a role for product management and for technical project management of people who have excellent systems and software design sense, but may be terrible coders. I think that's fine. Like, but what I don't think is okay is, like, if I want to have a conversation about designing a system and what constraints the system's going to have, and my boss is saying, like, I just think we need to do, 10K queries per second against a Paxos-backed system. Like, no, I want my boss to know what Paxos is. I want my boss to know that coherence of that sort is very, very expensive. Like, whether that person could today implement Paxos from scratch using, like, the academic paper and a keyboard and a compiler, that's not necessary, but I definitely don't want to work for anybody who doesn't know about distributed coherence and why reads and writes to it are going to be expensive. So yeah, so I think, like, I have pretty, like, I used to not have that high expectations, but it is amazingly liberatory. There was some thread when I first started at Google where something broke and someone did something, and someone from a team made some assertion. They were like, that's not true because we wrote that to that database and you must have lost it. And a VP came along and said, that's crap. I looked at your code and you're not even checking the error code on your connection to the database. So you can make no guarantees of what you did after that point. You're just doing stuff and hoping that it works out. I was like, I like working at a place where someone knows. There's a call you make to connect to a database. There is a connection. Like, the connection might have an error. If it has an error, you might need to do something different. So I think it's appropriate to have pretty high expectations. There was a good talk about careers, 2 days ago. And one of the questions people asked was, like, what do you do, like, if your bosses are clueless? That's tougher. The advice I think that was given, that was, man, you were in there. Yeah, you asked that question. The advice was go get another job, which I think is kind of harsh. You're like, oh, yeah, go get. All right, well, then, like, if you've heard that 4 times, dude, get another job. I don't know what to tell you. Like, I don't know your job, but, like, it sounds like you ask really smart people and they keep telling you to get a different job. So, but I do think, look, like, we're in a period where talented people are in short supply, and if you guys tolerate crappy management, we're all going to live with crappy management. So pick jobs where you ask questions of the people you're going to work for, and they answer them, and you come to an understanding that they understand how computers work, and they know something about networks. And maybe they have an expertise that's different from your expertise. Like, I've worked with people who are database experts. I've worked with people who know tons about networking, but nothing about systems engineering, right? I've worked with people who are amazing software engineers, but see, that didn't feel right. Do you know that feeling when it just doesn't feel right? And you're like, that's a lot of, that didn't. Really? Like, I think we're at like 4 or 5. Like, my fingers are like. What's that? Oh, it's a lot of characters, and there's, like, I don't know. See, I just.
You don't need the rest of the slides, right?
No, I probably don't. Yeah. Thank you very much. So anyway, my point is, like, if you guys could pick better managers, it'd be really, really good for the rest of us. Thanks. It'd actually be good for you too. Okay, so what do we actually do? Like, so people are like, well, if you're not going to do operations, what the hell are you going to do? We're going to do awesome, fun stuff. We're going to do 2 different kinds of things. One is we're going to build the platforms that all of us want. I don't know how to do that yet. I mean, I know some of it. I know some stuff I don't want. I think I know some stuff I want. I want John to ship his stuff faster, and then I want other cool stuff. Like, I know some of the stuff I want. I know some stuff I don't want. And I know I want to spend the rest of my time figuring out what else could we have, right? So I want to build that stuff. I want to work at a place where we get to build that stuff. And then I want to work at a place where we get to run that stuff and figure out how terrible we did it and go back and build it better. right? Because again, we talked about this, all the software is terrible. It's all terrible. And the software that we build that's awesome is going to be terrible. And then when we figure out why it's bad, we're going to go do it again. And we're going to keep doing that until we keep doing that, because we're never going to be done. So that's what I want to do. I want to build awesome platforms. I think there's a role for people who do physical engineering, data center engineering, people who do electrical engineering, people who build like awesome new hardware platforms that are cheap and scalable and amazing. I want to do infrastructure software engineering, where people are doing like OS abstractions and containerization work, and thinking about what is the API that we want to give people to run the jobs they run. Are these like magical migratable VMs? Are we going to run VMs as jobs on a distributed cluster? How are we going to do that? How are we going to think about that gives us the kind of security, management, configurability, portability, scalability properties we really need? What do we need, and what are the ways we can get that? I want to do all of that stuff. And then I want to work at a place where we run that and figure out how we did it wrong. So here's the, I mean, I think I've heard a lot of hallway conversations about this, but I think that the reality is system administration as a job title and as a role is in the middle, and it's getting squeezed. And I don't know how fast it's getting squeezed, but it's going to go away. It really is going to go away. And it's not going to go away because I'm cranky about operations. I mean, I don't have that kind of power or that kind of foresight. It's going to go away because we're going to get better at building things that require less futzing, right? So one of the things that happened is we had operating systems that required almost infinite futzing. Like the early OSs, you just had to do stuff all the time. I had to do all this stuff by hand. Cron jobs had to be hand edited, like disks, like remember like you had partitions and you had to like copy things off of partitions and make new partitions. You had to add individual disk drives to machines. It was terrible, right? But we did all that stuff and it was fun at the time, which is kind of weird. But anyway, so we did that. That was great. But that's mostly gone away. So one of the things that happened was machine count was going up like crazy as operating systems were becoming less obnoxious. But machine count was going up faster than operating systems were getting good. So we needed a lot of sysadmins. But we're at a series of plateaus right now where I think we've found a good set of abstractions, and we found a good set of operating system approaches, and we're going to need many, many fewer sysadmins, even as the machine count continues to grow. So that's the downside. The upside is there's going to be huge amounts of interesting stuff to do in the building of this set of infrastructure. And so I think like all the small companies have this like Windows sysadmin dude who's running like an Exchange server what I don't even know, what else do people run? They run Exchange servers, I know that. Sorry, go ahead. I'm going to figure out what else they run.
Yeah, I got to call bullshit. I'm sorry.
Okay.
There is no way you're going to squeeze the middle out. Not for small engineering sites, not for banks, not for small software houses, not for all these places, because you have such a dichotomy between the users who are not dumb in the things that they do, but they are not smart about how you can operate those systems. You have power users and you have non-power users.
Yep.
You're not going to be able to accommodate both in a single operating system or in a single configuration or in a single setup. You're always going to have that gap. And that's the one that the SA fills, is they're there not only just to support those systems, but also to support the users.
So if what you're saying is, yeah, so if what you're saying is like computers will continue to be hard to use and they will require on-site support, is that what you're saying?
Yeah, but it's going to go beyond. Most small businesses can't afford to have a help desk and an IT security person and an SA and this, that, and the other. It's all rolled up in one person, and
Sure.
It's usually somebody that didn't start in that position. They were a French major. So
French major?
You're not
French
gonna,
major right there?
Yeah,
No?
I mean
French?
I've known
What?
a ton of them. So you're not going to push them out. You can't, because they're still going to need that person, and whether their title is SA or their title is support desk or
No,
whatever.
I understand the point you're making, but I'm trying to figure out what are they going to do. Tell me 10 years from now, a real estate shop with 80 people. What is the person who is like that shop? It has 1 or 2 people who are system/network admins now, right?
Okay.
Okay. What are they going to do 10 years from now? Are they going to do exactly the same stuff? What are they going to do?
No, I think they will evolve. I think that's fairly clear through the way everything is changing in the security world, in the sysad world, in the networking world, and everything else. They will evolve, but there's always going to be a need for hands-on. There's always going to be a need for somebody to play with hardware and help out new hardware coming in and take the old hardware out as it falls off the end of the table. There's always going to be somebody to pull cable and set up switches and do those kinds of things. Even if there's software-defined switches, you still got to hang them.
Yep.
And I'm not saying that you won't have enough work for 10 essays in a space like that, but you probably have enough work for one.
Yeah, so I guess I can agree with that, but what I think is that that job gets a lot less interesting than it is now. In fact, that job gets so much less interesting that almost everyone I know who does anything like that job now wouldn't want that job in 10 years.
No disagreement, but you're also making an assumption that you're going to have users that want to follow a mold that you define, and I'll bet you're not. I'll bet you're going to have users that want to follow a mold of their own making, which is why most power users have the environment just the way they want it. It's why a lot of Mac users chafe at having to use Quartz. Even though it's great, it's plug and play, it's awesome, there are a lot of little features that people go, why are they doing this? We invented this 10 years ago. So I think you're always going to have that space. It's my 2 cents.
Interesting. I'm not sure I agree, but oh, sweet mother of God in heaven above. Ave Maria.
By the way, I just social engineered you so that you'd had to type your password again.
Oh, God, you're good at it. That was good. I gotta put my hands in my pockets to, I should say a rosary while I'm trying to get this to, Maria, Madre de Dios, el Señor es contigo bendito. Okay. Yeah, so that may be true. What I think and what I hope is going to happen is that client machines get massively better, whether it's, Macs are already like a Mac of today in spite of the little not configuring that sleeping thingy. Macs of today are massively less hassle than like the Windows 3.11 crap that we had years ago, right? So if they keep getting much, much better, if Chromebooks and anything like Chromebooks ever catch on because there's now bandwidth to do that, then I'm hoping clients get massively better. But you may be right. I think it's going to be pretty dreary work in the middle. And I think there's going to be a huge need for distributed application development. And for those of you who think you might want to write some software, there's going to be a lot of people who don't understand what it means to run a distributed job. And I think you could play a significant role in that. Pictures of data centers just to distract you. John showed those. So here's what I think are the babies in the bathwater of where I think we're going to go. This is this weird metaphor for the non-native English speakers of what is it? It's don't throw the baby out with the bathwater, which is such a weird thought because like anybody who's ever had a baby, seriously, you bathe them in the sink and you can't throw out the sink. Like it doesn't make any sense, right? But anyway, maybe that was just me. I bathe my babies in the sink. So I want to keep the production ethic, but I want to get rid of all of the repeatable work. I desperately want to keep the troubleshooting. Like, you guys, people who come from a systems and a network engineering background, best troubleshooters ever, because you're like, the world's really complicated. Here's a problem right in the middle of it. You're like, oh, cool. I have no idea. Let me figure that out. That's amazing, right? I want to keep that. But I want to get rid of I want to throw out any work that could be automated. I want to throw out all the one-off crap you do, like let me just write this little bad shell script to do this thing. I don't want to do that. It's terrible. I want to get rid of OS configuration management, but keep and build some kind of an intent-based or constraint-based system configuration management. I want to keep release engineering, canarying, and testing and rollout, but I want it to be automated. Like I want to be able to trust the whole thing so that when I check in code, I know it either works or it doesn't. If it doesn't work, it's never going to go out. If it does work, or I think it works, it's going to go out and it'll get canaried automatically and there'll be some set of constraints, yes? You have to go to a mic. Well, somebody throw a mic. Okay.
How can you tell if you can trust the automata if you don't have any humans anymore?
Well, so what, I'm not sure. So the question was, how can you tell if you can trust the automata if you don't have any humans anymore? I don't know. Do we, like, humans don't inspect packets as they cross 10 gig links. But we're pretty sure the packets are good, right? Like, not in this particular wireless network, but in other places where they have internet. So yeah, I guess I don't agree with the question at all, right? When you do a production rollout of some software, you should know whether it's good or not. And the answer to whether it's good or not is some series of values or tests. Like, does it give the right answer? Does it match the golden set? Is it slow? Is it throwing errors? Is the help desk calling? Did I load the one page and it seems fine? Whatever weird little thing, like that's what you do to see if you did it right. So I want to keep capacity planning for sure. It's going to be something everyone's going to have to do a lot more of. I want to keep SLA definition and SLA monitoring, and I want to do a lot more of that because I think that's going to help us do our jobs better. I definitely want to keep that constructive cynicism. Hegelian dialectics, you can't give a talk without Hegelian dialectics. Everyone knows that. So here's the, you guys got the Hegelian dialectics? It's awesome, yeah. Who here loves Hegel? That is way more than I thought. That is fantastic. Right, Kant, anyone? No, okay. I was just kidding about the Kant. No, I really wasn't. Oh, Jesus Christ. So, look, here's the TLDR. The industry moves pretty fast. And if you don't stop and look around once in a while, you could miss it. I'm claiming it's moving pretty fast right now, and it's a good time to stop and take a day off of school and go to a ball game. I heard it multiple times, and I'll say it again, like those of us from a systems background should massively improve our software skills, improve your algorithm skills, improve your fluency in software. This is not magic, and most of the people who are employed as developers are terrible, and most of you have much, much better software skills than most of the people who make money writing software, and you should just get over it. Like just sit down and write some software. Write it in Python, write it in Go, write it in Perl, write it in C. And don't be afraid of C and C++ and Java, right? Like, I mean, be afraid of Java because those class paths are enormous, right? You're like, oh my God. And a factory, impl, factory, decorator, factory, impl, builder, right? But anyway, like, don't be afraid of that stuff. It's really not rocket science, and you can figure it out. And it's stuff that you are much, much better at than most of the people who get paid to do this for a living. Drop the nostalgia of earlier days. We don't need heroes. We don't need war stories. What we need to do is collectively invent a better future. And if you think I'm totally wrong, I don't actually care if you think I'm totally wrong about the direction I think we're headed. What I care about is that you're willing to admit that we could do way better than we're doing now, that we deserve it, that we owe ourselves to have a way, way better internet and a way, way better operations culture and a way, way better production culture than we have now. So thanks. Other questions that weren't worked in the middle? Yes? You got there first. It's a race.
I was already
Go.
back to my seat, so okay. When I first heard Adrian's no-ops move, is this better? Mm-hmm. Cool. When I first heard Adrian's no-ops movement, I had a pretty violent reaction to it. But after listening to your talk and openly kind of like entertaining the idea, I think I'm a little more okay with it. But I'm reminded of a maxim we've had in the system administration world for a long time, and that's automate yourself out of a job.
Yep.
I wonder what you think about whether or not in the current environment that is actually a more obtainable goal than it used to be, where we kind of always seem to be fighting against the onslaught of Jesus Christ, there's so much to do, you know. Is it better now?
I think it's somewhat better now. I think there's a set of things that we used to have to automate that are now solved, partly by people like us, right? So that's great. The problem is that we're still on some exponential growth curves. Like there's a lot of people in the world who aren't even online yet. A lot of people, and right, they're going to want stuff. They're going to want to buy stuff and sell stuff, and ship bits around and share pictures of cute little kittens. And there's going to be stuff that we're going to have to do that we haven't figured out yet. So I do think that the problems that we face now are bigger, but they're more interesting. So yeah, that's a Weasley non-answer. That was good. I like that. Yes.
Hi, I'd mentioned we don't want to ignore the past either. Something I see interesting with the DevOps and configuration automation, now things where you want to have like bare metal deployment or VM deployment where you load some shim that figures out how to get the ball rolling, and then something like Puppet or Chef then runs to finish out the rest of your configuration. But in terms of going from blank system, nothing installed, to something configured and running, we've actually seen this for at least a decade in the high performance computing scene.
Yep.
So I'm not saying I want to reuse what I was using a decade ago for system deployment because I know it sucked, but we've had something like that, and there's some elements I borrow from it. I don't want to completely ignore the past work that's been done, but I just want to take the pieces that worked.
Yeah, so there's an interesting point around that like happens to all of us as we turn into old farts. No offense intended, that was about me, not you, but if you're here with me, we can be old together. That like it's frustrating when you see the same thing you already did and somebody like heralds it as new. They're like, look at this new thing. And you're like, wow, we tried that back in the day and it didn't work because, but like, so I think there's a good part of that and a bad part of that. The good part about that is, like, we made some mistakes and there were a bunch of things that didn't work, and let's not make those again, or let's at least try to understand whether those same constraints that we were under still apply. That's important, I totally agree, right? So, but what I don't want to do is slow anyone down, right? So if somebody else wants to reinvent the wheel and they do it in a way that's like accessible to a large number of people, like what if Chef were like, whatever, completely reinvent something that existed on like VMS? So what? Like we don't have VMS, right? So to some extent, I'm like, if people think it's new and that's part of what motivates them and gets them excited, I don't want to slow them down saying, well, you need to do a study of all the prior work here and fill in this portion of the design doc, because otherwise, like, it's not going to work out. So I'm mixed. I'm sympathetic that it would be nice to avoid mistakes and it would be nice for people to have a richer sense of what's been tried and what's failed. But at the same sense, I'm pretty sympathetic to like people who are relatively young with a relatively large amount of ambition who just want to solve some problems. So.
I would say it's a balance. I know I'll take on something myself because either a solution doesn't exist or the solution is too damn expensive.
What about the case where the solution may not apply or you don't even know about the solution? Like how much time, this is like, sysadmins on the internet have been doing this forever. How much time do you spend looking for the thing before you start writing it, right? We all have that like, I'm gonna look, screw it, I'm gonna write it, right? And like right after you write it, you find the thing that's already done that's way better than the thing you do. It always happens, but it doesn't matter because you can't just keep looking. Like, there's some provable like rule 42, but for systems automation that's like the thing you want exists. It totally exists. It's just going to be really hard to find it. So I think we can do more to talk in a structured, accessible way about the ways we've tried to solve these problems in the past and what success we've had and what failures we've had. But we need to if you've got some interesting notions about bare metal configuration and what works and what doesn't from the HPC world, it's up to you to make that accessible and really easy to find. Because I would rather have somebody writing software that solves the same problem you already solved, making the same mistake in a useful way, than spending time trying to figure out what happened.
I can tell you the big difference. In the HPC world, it's homogeneous machines, whereas when you have varying VMs of different sizes or their EC2 instances, it's heterogeneous configuration. That's the big pain.
Okay, excellent, thanks. Yes?
Quick thought. The computer as an abstraction or as a concept to discuss problems around can be somewhat limiting, which is, I think, one of the main conclusions. If you think about running things on servers, it kind of limits you. On the other hand, it's very hard to move out of that if you want to talk to people outside of your specific company, in this case, Google. Googlers tend to talk about things as jobs and things like that. And the concepts doesn't really translate into things outside. What would be sort of a bootstrapping process to get the rest of the world to move outside of the concept of running servers?
No, like that's a great question. Sorry, what's the answer to that question?
I'm just trying to find out why we're failing at moving forward and building the better world that you're talking about. And I think that's one of the...
No, it's because I think there's, like, you're absolutely right. You're absolutely right that, like, that's the question, right? And the question is there's a discontinuity between at least where I'd like to get to in an intermediate state and where we are now, and it's a sharp discontinuity. I don't know. You know how to bridge it? This is awesome.
Actually, I was going to ask something really similar to this because I'm on board with this.
You got to lean in, or the audio guy's going to yell at me.
I'm on board with this, but so I guess what I come to understand is that, like, in Google you have hardware ops, so you can divest like a sysadmin from doing hardware work.
Sure.
So how can, exactly this, how can I get management to be on board with this? How can I get them to drink the Kool-Aid of like being like, hey, let me do this SRE stuff, and we get some hardware person to deal with this, so we can abstract away?
Yeah, so I mean, if you're, there's only, in the end, I think we're likely to move towards a world where there's maybe small, medium, large organizations, and like very large organizations may end up being providers of this kind of service, right? They're like, I will be Amazon. Like Amazon's your HWAPs, right? Like, go get them to schlep your servers around for you, and you're like, I'd like another one. I'd like another one, right? Oh, there's a bunch of cloud service providers here that do not only that, but provide you an infrastructure stack that you can run on, right? So that's going to be one model, and that's going to be totally appropriate for certain kinds of things. There is going to be another model of people who want to keep running computation closer to users, either because of speed of light issues or because of privacy or data security issues. And that, it's less clear to me how we solve that other than much, much better hardware that's more standardized, that's more replicated, right?
But I think the question still remains, how do you get like management who are very used to kind of like the old school role of sysadmins and devs and all these different siloed kind of fields, how do you get them on board to saying like, okay, we'll push away from that?
It just moved
Todd,
it.
although I would love to let this thing go and have you type your password another 37 times so we could do some really fun things, I have been asked to call time on this one because we have to give up the room.
Awesome.
So if we could take this offline, thank you very much, Todd.
Excellent.